Hello everyone. In this video, you will see how to align the interferometer that goes with the air bearing stage that you will use for the Student Challenge 2023. Right now, you're looking at the pre-clamped bearing stage, which you will receive. I went ahead and mounted two pH 1.5 optical post holders from Thorlabs. Here I've attached the optical posts to the laser clamps, which you can tighten with set screws. I've held it in a way it's slightly loose so that I can put them into these post holders. You can hold it right there. Let's go ahead and tighten the set screws so that the laser is held well in the clamps. Once that's done, by loosening the post holders, you can raise the laser up and down. We're gonna try to get the laser height about 95 millimeters. It can be plus or minus a couple of millimeters. I went ahead and mounted the turning mirror via this MIG block to the optical post going to this holder. Let's mount it here. Give it room so that it sticks out like this. And let's go ahead and turn the laser on. And, give it a few seconds before it fires up. Now the laser is on. Let's put the turning mirror so that the beam hits the mirror. Now we're gonna try to align the beam from the mirror in parallel with the breadboard surface here. It doesn't have to be too good. I'm gonna use this checked sheet of paper stuck on this cardboard box. And I'm gonna use the surface of the breadboard here. So if you drag the box, you can see the beam will move right and then slightly low. We're gonna try to align the beam such that as we drag it along, it stays in the fairly the same spot. While you drag the box along the edge, you can see the beam moves right. So we're gonna try to align the mirror so that this beam doesn't shift right or left. So as you move the box this way, the beam moves right, so we need to turn the mirror that way. Still moves towards the right. After aligning the turning mirror, you can see the beam's not moving right and left like before, but you can see it's moving slightly up and down. We don't have any pitch control for the turning mirror. As I said earlier, the angular alignment of the turning mirror doesn't have to be too good, because the end goal is to align the stage travel with respect to the beam, right? For that, we'll use this tip tilt adjuster on which the polarized beam splitter is attached, and you can adjust the height of this aligner and move it laterally. It's attached to this med block. Let's go ahead and attach this to the breadboard using quarter 20 screws. Now we finish mounting the polarized beam splitter on. You should see if the laser beams going through the hole to go through the polarized beam splitter, but it doesn't. Therefore, move this turning mirror slightly behind so the beam makes it through the beam splitter. And if you are worried about the change in the yaw angle, you basically unmount the beam splitter, and you can see it moved slightly to the right. So you come back and realign it, and again make sure if the beam goes through the hole of the polarized beam splitter. Now we align the turning mirror such that the beam goes through the polarized beam splitter on both sides. Let's go ahead and mount the corner cubes. There will be a short one and a larger one. The short one goes on the stage. Make sure to use the M6 screw. One thing we need to make sure is the beam coming from the which transmits through the beam splitter and which reflects from the beam splitter, they need to be of almost of the equal intensity. If they are not equally intense, you have to loosen the set screws of the laser. And rotate it such that the intensity is almost equal on both sides. I would say that's pretty good. Let's go ahead and tighten the set screws. So after you mount the corner cubes, you can move it right and left so that the beam from the corner cube gets back through the beam splitter. Also, you might notice this corner cube is in a slight angle. This is to avoid the laser beam going from the front face of the corner cube, which doesn't have anti-reflection coating on it. So you don't want that to go back to the laser, so that will destabilize the laser. So having it in an angle reflects this front face reflection off to somewhere. We also adjust the corner cubes vertically and laterally such that the beam doesn't go to the center of the corner cube, which will again send the laser, some of the light back to the laser source, which you don't want. So we have to offset the beam going to the center of the corner cube to the right and left, or to the top and down. Here you can notice it's coming slightly below from the corner cube and goes and still goes back to the laser, but slightly below the point where it's coming from, so it won't get back into the laser cavity. After aligning the corner cubes, we can see the two beams from the two corner cubes coming out, and these two are back reflection from the front surface of the corner cube. You can see if I loosen it and change the angle of the cube, those vanish, and these two still remains, which is the beams we want to interfere. I'm gonna move this reference corner cube up and down and move it laterally such that we can interfere the beams coming from the two corner cubes on top of the other. Moving this vertically. And laterally. I'm going to see how well they are on top of the other by blocking one at a time. I think that's reasonably aligned. I went ahead and turned the air compressor on so that we can move the stage back and forth. As you can see here, as I move the stage, the beam from the corner cube is moving right and left. This is because the stage axis is not aligned to the axis of the beam that's coming from the polarized beam splitter. So since we can't move the stage, we're gonna adjust the angle of the polarized beam splitter so that this lateral shift doesn't happen. Since it moves laterally, I'm gonna use the yaw screw. You may notice the shift has reduced a little bit as I adjusted that screw. Let's make it worse. Right, it moves quite a lot. Moves less compared to earlier. As you keep doing this, you'll notice at some point the light doesn't go back into the beam splitter anymore. So to adjust for that, we need to laterally shift the beam splitter and repeat the process. I'm intentionally misaligning it so that you can see the lateral shift. Let's align it back. Yeah, blocking the reference corner cube, you can see the beam's not moving right and left anymore. If the beam's going up and down, you'll use the pitch screw to align for that. Now that the laser beam is aligned to the travel stage, let's go ahead and mount the 50-50 beam splitter. Now that we have aligned the laser beam to be in line with the stage travel, let's go ahead and assemble the 50-50 beam splitter. So now the beam splitter is, the 50-50 splitter is assembled such that the beams reflect and transmit through it. Let's go ahead and assemble the photodetectors. Now that we have mounted the photodetectors such a way the beams are near the holes of the photodetector, but you can notice that the beams don't exactly go through the holes. For that, use the optical post to raise it or lower it in this case. And if it's not going through the hole, it's misaligned laterally, you can loosen the base here and move it right and left to fine adjust the photodetector such that the beam goes through the hole well and hit the photodetector, the diode inside the box here. You can come down and loosen this screw, and then you can move the photodetector right and left, forward and backward.